Good evening. Today we want to learn on the bubble sort. The bubble sort, bubble sort, bubble sort, bubble sorting. Uh, Bubble sorting is one of sorting algorithms that are used to arrange elements within a list in a specified or in a well-defined order. It might be an ascending order, it might be in descending order. So we want to learn about the bubble sort. How does it perform the sorting? And we have to demonstrate using codes what we are going to discuss, what we are going to share with one another. Right? Imagine we have numbers like 78, 41, 56, 62, 81, 53, 45, 71, 64. Right, and the last to be 32. Right, something like this. Right. So the bubble sort, the way it works, it compares two adjacent elements, and if they are in the desired order, it moves to compare the last compared plus another new one to make two adjacent. So it compares two adjacent elements per given instance. Like in this scenario, we have 78 and 41. So these two elements will be compared first. If they are in the desired order, it compares 41 and 56. But if 78 and 41, they are not in the desired order, a swap must occur, and that swap has to be recorded that there is a swap which occurred. Meaning to say that when the algorithm moves from the first element to the last element and there is no swap which took place, it means the elements are now in the order which has been desired. That's what it means. But if there is a swap, it means it has to traverse the list. It has to move again from the beginning of the list to the end of the list, trying to compare adjacent elements and to see whether they are in the desired order. So that's it. Like in this scenario, let's say we want to arrange these numbers in ascending order. It means 78 and 48, they are not in the desired order because 78 is greater than 41. So we mean what it means is 41 has to come where 78 is, and 78 goes where 41 is, something like this. We have our 41 here, we have our 78 here. Right, then 78 is compared with 56. Still the order is not desirable, so 56 will come here, then we have 78 here. Again, 78 is compared with 62. Still the order is not desirable, 62 will come there, then our 78 goes there. Then compare 78 and 81. That one is a desirable order, so it remains like that. Then you move to the next 81 versus 53. 53 is not the order is not desirable. 53 we have to swap with 81 like this. We compare 81 with the 45. Again, the order is not desirable, so 45 goes there, 81 goes there. 71 versus is 81. Again, it's not desirable. 71 comes here, 81 goes there. We compare 81 and 64. it's not desirable because we are sorting in ascending order. So 64 will come there and 81 will be there. We compare 81 plus not plus but 81 and what and 32, still is not desirable. 32 comes there and 81 becomes here. So this one will be known as a pass. So that pass now, then after the algorithm reaches the last element, what it means is the last element is sorted, and truly 81 is on its position. That when we talk about that the element has been sorted, we mean that the element is on its position. That's what it means. So 81 in this scenario is now on its position, and the rest of the elements are not on their positions. They need to be what? To be sorted. So that's how the bubble, that's how it acquired the term bubble, because it seems as if it's arranging the elements in ascending order, it will be bubbling the bigger numbers towards the right side, bubbling like the numbers are being bubbled towards the what? The end of the list. That's how it assumed the name what? The name bubble sort. So now we want to write a program using our description that we have to repeat the iteration as the yes, we need to iterate the comparison of the adjacent elements as long as there is a swap which occurred. So we need to take that into consideration. We have our list, we have the swapped, which might be declared as a blend because it will be turned false. If there is no swap, it has to remain false. If there was a swap, then it has to be turned on to show that there was a swap. So as long as there was a swap, we need to continue what? Iterate. That's so those are some of the variables which we needed to take into consideration when we are now writing our program, right? You want to rename this to bubble sort. Yes, that's what I want. Right, come here, we declare our list and call a list as integer equals to I paste. Oh, I just copied the 2. I want to copy all these numbers, right? What is remaining is only putting the commas. The last element, sorry, the last element, right? We need to have a variable which obviously will be called is swapped, right? So dim is swapped as boolean has to begin probably on the true, so that we will be able to enter the loop, because we are going to use a conditional loop. I prefer the while loop in this scenario. So for us to enter the while loop, that boolean has to be first true, but we are going to turn it off the moment we enter the loop. We turn it off so that it is turned on when we are iterating the what the list. That's then we need some variables, like because when we swap, we need a third container to hold the what before you complete our operation of swapping. Like it's similar, like if you have two cups, one with sugar and another one with the salt, and you want the one with the sugar to end up with the salt and the one with the salt to end up with what, with the sugar, then obviously you need a third cup, so that you pour probably the sugar on the third cup, you take salt, you pour on the cup which was having sugar, and you pour that one from the temporary to the one which was holding the salt, you pour the sugar. So that's the temp which we're declaring here. Can you probably even use the declare the index I if you want to use it. Then we may also want to declare probably the lower bound if you need to use the lower bound, but there is no need, because yeah, sometimes you may need to declare probably the upper bound, because the lower bound we know that this is the lower bound up as integer, right? Then we assign the upper bound equals to a list dot length. This is the length returns. If you want to see this, it's a property. It gets the total number of elements in all the dimensions of an array. So in this scenario, we are saying it returns the total number of elements. So we need to minus one for us to get the what, the upper bound, right? We will add some of the variables if need be after seeing the need of having them. So let us now try to iterate using a while. While is swapped. What it means is while is swapped equals to true. Then you can now enter the what? Enter the loop. So we turn the what? The swapped equals to false. Because it has to be turned when we are now iterating the what? The list now. For I equals to 0, 2, up, minus 1. Now what it means is this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have these elements, probably they are 10, not probably, but the elements are 10. So 10 minus 1 we get 9 if I counted it correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So but still here our up is 9, but I minus the 1 from the up. The reason being is that we are going to compare two adjacent elements. So if you reach the 8th index, we need to say 8 plus the what, the 9th. That's why I'm subtracting what, 1. Because if you don't leave that, if you reach this point, you want to compare the 9th and the 10th, and then we don't have the 10th, so it will have out of bounds exception. That's why we subtracted 1 on what, on up minus 1, because some may get confused here, because we said length minus 1, that is the up, means that the up is now 10 minus 1, which is 9. Then here we come, we say up minus 1, it becomes confusion. So I just wanted to clarify, to clear the confusion, and I hope I managed to clear the confusion, because what we want here is to make you grasp the concept, not to create confusion. Right now, we now want to make the decision making. If a list I, because we are comparing, we are sorting in ascending order. So if I is greater than a list I plus 1, then what it means, there is need for a swap. I think if 78 is greater than 41, like what we did, there is need for swapping, so we swap. So now we are performing the what, the swapping now. Let me just comment so that people will know that here we are now performing the swapping. So a list I, or not a list, we start first, we need to load the what, the temp. So temp equals to a list I, right? a list I, since it is the value has been placed in temp, let us now give it its new value. A list I plus 1, then a list I plus 1 equals to temp. So these are three containers if you look at very well. First, the value of a list I is copied to temp. Then the value of a list I plus 1 is copied to a list I. Then the value of temp, which was of a list 1, is now placed. So in other words, we have swapped 78 and 41. That's what has been done here. Right. Next I. Then the moment if there is a swap, so is swapped has to be turned to true. Right, like this. Then after then a while, we can even display the loop, the array I mean. Can display using probably even for each num is integer in a list. Then we display console dot write num and vp tab. Right, you can say console dot write line sorted a list. Right, we need to see what we are doing here. So let us copy this and put it before this one, and we say the unsorted list. Right, so we want this right line so that we create a blank here, because things will get out of hand. Let's also add more lines, more blank lines. Right, we can even run now to see whether the numbers are going to be sorted or not. If they are not, then we have to check where we made it wrong so that we can correct. Right, this is 78, 41, 56, 62, 81, 53. This is the first unsorted, and this one is now 31, 42, 45, 53, 60. Yeah, this is now sorted. This is now sorted. Right, we need to see the actual sorting. So for us to see the actual sorting, what we need to see, what we need to do is to probably display after every pass. So we need to put this line. Right, let us put this line here. Right, then the other one, say, so this one is now during sorting, right? And just say the sorting process. We need to see the sorting process. Right, so on the sorting process, we now want to see how these numbers will be what will be sorted. Right, we must have a right line here, a blank right line, which will make elements or to be moved to the next line. Right. Let us try to run to see whether the sorting process, the numbers will be sorted accordingly. Yes, you see, like this is the first pass. 81 will be sorted, 78 will be sorted, 71 will be sorted, 64 will be sorted, 62 will be sorted, 56 will be sorted, 53 will be sorted, 45 will be sorted, 41 will be sorted, and 32 will be sorted. So that's the whole idea here. So that's the unsorted, the sorting process, and the finally sorted. Because this and this are the same, the last year and the, because it will stop only if there is no pass which occurred. Otherwise, that's the bubble sort for you. And I hope I assisted one another on this one, on the bubble sort. This is how you go about it. Yes, don't confuse with the right lines which I put. They're only there to make our output more clear and more readable. But some may not even talk about those console right line, they are meant to make sure that our output is readable. That's why we put those right lines. Otherwise, that's the end of the what? Of the bubble sort. I hope we have grasped it, and don't forget to do the what? The usual one.